Hi everybody, welcome back to the second semester of Algebra 2 Pre-AP IB. To start off today's lesson, we are going to revisit the most missed questions on the fall semester exam. So what I want you to do is I want you to hit pause, work these 5 problems, and then when you're ready to check your work, hit play. All right, welcome back. So I have highlighted the correct answer choice for each of the 5 questions. So check your work and see how you did. Okay, now let's review some graphing from the first semester. So what we need you to do again is hit pause on the video, graph these 3 equations, and then when you're ready to check your work, hit play and see how you did. Okay, welcome back. Do these look like your graphs? These are the correct answers to number 31, 32, and 33. Let's get started on our lesson. Now, one thing we want to point out before we begin is that the next 4 units are going to be labeled Unit 5A, Unit 5B, Unit 5C, Unit 5D. Now, all 4 of these units are kind of subsets of the bigger unit, which is polynomials. So what we've done to make it a little less daunting is we have broken them up into sub-units. Okay, so 5A, 5B, 5C, 5D deal with specific types of polynomials. Now, don't panic. There's not going to be one big test at the end for over all of Unit 5. No. Basically, each unit is going to have its own quiz and test. Okay, a couple of the units will only have quizzes, and then the other 2 units will have a quiz and a test. So just know that's our way of breaking up the polynomial unit into more digestible chunks. All right, so we are going to move on today, and we're going to talk about attributes and transformations of square root functions. Now, Unit 5A is all about the square root function and square root equations. Now, the cool thing about this unit is it's only 3 days. And then at the end of those 3 days, on the 4th day, we will take a quiz over this unit, and that's it. After that, we'll move on to the next unit. So this unit only has a quiz. All right? So today, we're going to be talking about attributes and transformations of square root functions, meaning we're going to learn how to graph square root functions from the parent function. So let's recall back from Unit 1 when we talked about inverse of functions. So if you remember, when we saw f to the negative 1 of x, that really means find the inverse of f of x. So if you will recall, that means we simply switch x and y, and then we resolve for y. So to find the inverse of any function, we're going to switch the x and the y, and then resolve that equation for y. Now, let's revisit from our last unit, that was Unit 4, back before winter break. We talked about the quadratic functions and equations. And that was y equals x squared. Now, if you remember, your parent function of the quadratic was negative 2, negative 1, 0, 1, and 2 for the x's, and then 4, 1, 0, 1, 4 for the y's. This is the parent function of the quadratic function. So graphically, that's what it looked like. Was that a function? Yes, a quadratic function is a function. So let's talk about its domain and range. Now, the domain of any quadratic function is always negative infinity to infinity. And if you remember the range of the parent function was 0 to infinity. So that's what we talked about before winter break. All right, now let's find the inverse of f of x. So if you remember, we start with our original equation, then we switch x and y, and now we have to solve for y. Well, y is being squared, so how do I undo the square? I take the square root. So I square root both sides. Now because I put the radical on there, that was me, I put the square root. So since I put the square root, I have to include a plus or minus. So that's how we find the algebraic inverse. Now when we're looking at a table, remember to find the inverse, all you have to do is you have to switch the x's and the y's. Now let's see what that looks like graphically. So it looks like a parabola that it went from opening up to it kind of did a 90-degree rotation, and now it's opening to the right. So the inverse opens to the right. Now let's talk. Is this a function though? Because when I graph it, will it meet all the requirements for a function? Well, let's try the vertical line test. If I pass a vertical line straight through that parabola, I'm going to intersect that parabola twice. So it's not a function. So the algebraic inverse of the quadratic function is not a function. But we can still talk about domain and range, because remember, when you switch x and y, your domain and range switch as well. So my domain is now 0 to infinity, and my range is negative infinity to infinity. Now, the algebraic inverse of the quadratic is not a function, but we can do something called restricting the domain. So, since the inverse of f of x is not a function, we can restrict the domain of the original function so that f of x will be a function. Okay? So, what we're going to do is we are only going to do the positive x's. Okay, we're only going to look at the positive x values. So we are going to restrict our domain on the quadratic. If we look at a quadratic and we restrict the domain to be only 0 to infinity, then when we form the inverse, that's going to give us a function or a graph that is a function. So if we look at and we restrict the domain of the quadratic function so that we're only looking at positive x's, because we can't have negative x's, because remember, we don't like negatives underneath the radical. Okay, so we don't want negative x's. So we only look at the positive x's so that when it reflects over y equals x, we get an inverse that is a function. All right? So again, to restrict the domain of the quadratic, you only look at the positive x's, which gives you a new domain of 0 to infinity, so that when you reflect it over y equals x to form the inverse, you only get the top half of that curve. All right, let's look at this. So now we're going to talk about transforming the square root function. Okay, so most of this information on this slide has not changed, but let's talk about what has. First of all, the transformation equation has changed because now we're dealing with the square root. So you'll notice that it's a on the outside of the radical, so it's a times the square root of b times x minus h, all underneath the radical, plus k. And k is on the outside of the radical. Now this chart, nothing has changed. Okay, b and h are still inside the function, which inside in this case means underneath the radical. Okay, so it's going to be opposite day for b and h. That has not changed. Now, square roots don't have a vertex, but they do have kind of a starting point. So we call that starting point the initial point. And to get that starting or initial point, that's going to be h comma k. Now, PEMDAS says that we still multiply or divide before we add or subtract. Now, what has changed? Okay, so let's talk about the domain. Now, if your b is positive, okay, if your b is positive, your square root is going to increase to the right. So your domain is going to be h to infinity. If your b is negative, okay, remember if b is negative, it's going to reflect it over that y-axis. So it's going to go to the left side instead. It's going to start at that initial point and go to the left. So if b is negative, it's going to be negative infinity to h. Now, let's talk about the range. The range, if a is positive, it's going to increase to the right. So your range would be k to infinity. If a is negative, remember if a is negative, that causes it to reflect over the x. So your range would be negative infinity to k. Now, x-intercept is still where y equals 0, and the y-intercept is where x equals 0. So, like I said, not a whole lot has changed, just a couple of things you want to make sure you take note of. All right, let's jump in here and graph an example. So our first example is y equals 4 times the square root of x plus 9 minus 8. So let's talk about that transformation. So plus 9. So that's describing left or right movement. So remember it's opposite day, so that's really going to be that we're going left 9. Okay, so we're going to be going left 9. This minus 8 tells me we're going to be going down 8. And then this 4, because it's bigger than 1 and it's outside, that tells me it's going to be a vertical stretch of 4. So we're going to be going left 9, down 8, and a vertical stretch of 4. So what's my initial point? So remember, it's hk. Well, it's really x minus h. So therefore, your h value is negative 9, and your k value is negative 8. So when we graph, we always start with the parent function. So if you remember back when we did the parent functions and we introduced all 6 of the parent functions, this was the square root parent function. The x's are 0, 1, 4, 9, and 16, and the y values are 0, 1, 2, 3, and 4. Now we're going to graph. Now, just a word of warning. This is the way we want you to graph. When you see questions like this on a quiz or on a test or whatever, and we say we want the new table, we want the transformation table. So this is not going to be a situation where you can plug this into your calculator and just spit out what the calculator tells you. We want the transformational table that is formed when you take the parent function and you add, subtract, multiply, and divide. Okay, so this green table, that's what you would give back to us on a test or quiz. All right, so how do we go from old x's to new x's? How do we go from old x's to new x's? Well, there is no b value, so we don't have to worry about that, but there is an h value, and it says x plus 9, but remember, it's opposite day. So instead of doing plus 9, we're really going to subtract 9. So 0 minus 9 is negative 9, 1 minus 9 is negative 8, 4 minus 9 is negative 5, 9 minus 9 is 0, 16 minus 9 is 7. Now, to go from old y's to new y's, remember a and k affect the y values. So we have them, and we do those at face value. A and k, no opposite day. No. Okay, so a and k, you do exactly what it says. So it says multiply by 4 and subtract 8. So I have to think, which one am I going to do first? Am I going to multiply or subtract? Well, according to PEMDAS, PEMDAS says we multiply and then we subtract. So I'm going to multiply by 4 and subtract 8. So 0 times 4 is 4, minus 8 is negative 8. 1 times 4 is 4, minus 8, negative 4. 2 times 4 is 8, minus 8 is 0. 3 times 4 is 12, minus 8 is 4. 4 times 4 is 16, minus 8 is 8. So I plot all 5 of those points and I connect the dots. Now remember, do not put an arrow on that initial point. If you put an arrow on that initial point, your whole graph will be wrong because it does not keep going in the left direction. It is starting at -9 to -9, -8, and it's continuing and increasing to the right. Okay? So remember, square root functions only have one arrow. Let's talk about the domain. Well, my smallest x value is -9, and I can touch that point on my graph. And then it just keeps going all the x's to the right all the way till infinity. So our domain is going to be -9 to infinity. My range, well, my smallest y value is -8. So, but then that keeps increasing, 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 increasing. So my range is going to be -8 to infinity. Let's continue on with this example. Now they want us to take this equation and find the maximum over the closed interval -13 to 7. Well, because we've got that initial point, we kind of do have to treat it a little bit like a vertex. So the max or min over an interval will occur at the endpoints of the interval or at the initial point if it's inside the interval. So remember, we have left and right. So this is where we're going to go back to doing f of L, f of H, f of R. So I know my left and right. My left is -13, my right is 7. Now my H, x plus 9. So that means my H is -9. Now before I do any math, I have to look and see, is -9 in between -13 and 7? Is it? Yeah. So since it is, we have to figure it out. So I plug in -13, then I plug in -9, and then I plug in 7. So this is the first round of substitutions, and then I clean it up. So -13 plus 9 is -4. Okay, I know we can have imaginary numbers, but not when we're dealing with max and mins. So right now, is it legal to have a negative underneath that square root? The answer is no. Okay, so it's not possible. So since we got a negative under the square root, it's completely thrown out to begin with. Plus, if you think about it, my graph really doesn't start till -9. So -13 is like not even on the graph. So now -9 plus 9 is 0. Square root of 0 is 0. Okay. 7 plus 9 is 16. Square root of 16 is 4. So for f of -9, I get -8. And f of 7, I get 8. So we want to know which one is the maximum. Well, f of 7 equals 8 is our maximum. Now remember, that's exactly how we want you to write your answers. F of 7 equals 8 max. Okay, so that's how we want your answer written. Now, let's do the minimum. What if I want the minimum over the interval -5 to 0? So I still have L and R, so I have to do f of L, f of H, f of R. My H is still -9. But wait a minute before I go on. Is -9 in between -5 and 0? I don't believe so, Scrooger. So since -9 is not in between -5 and 0, we don't have to figure him. So we just have to plug in -5 and 0 and find out what we get. So -5 plus 9 is the square root of 4. Okay, 0 plus 9 is 9. So square root of 4 is 2, square root of 9 is 3. Keep evaluating. So I get that f of -5 equals 0 and f of 0 equals 4. I want the minimum though, so the smallest value is 0. So I would say that f of -5 equals 0 is my minimum. Now, over what interval of the domain is the function increasing? Well, here's the cool thing about the square root function. It's either strictly increasing or strictly decreasing. So since this function is strictly increasing, the interval that it's increasing over is just the domain. So when they ask you over what interval is the domain increasing, you just give the domain of the function, which in this case is -9 to infinity. Now, if they'd asked you over what interval is the function decreasing, you would have said none, because this function is strictly increasing. However, if a was negative and it decreased to the right, so it went down and to the right, then and if they said what is the interval, over what interval is the domain decreasing, you would then give the domain of the decreasing. So basically the point of this is, if they ask you over what interval of the domain is the function increasing or decreasing, it's basically the domain, okay? Because a squared function is either strictly increasing or strictly decreasing. There aren't any points where we go increasing, now we're decreasing, increasing, now we're decreasing. So it's strictly one or the other. Okay, let's talk about finding the x and y intercepts. So let's find the x-intercept. The x-intercept is where the y value equals 0. It's where the y value equals 0. So we plug in 0 for y. Now, just like we would do if it was an absolute value or if it was a quadratic, we need to get that function piece by itself. So that means we need to get the square root completely by itself. So the first thing I'm going to do is I'm going to add 8. So that gets me 8 equals 4 times the square root of x plus 9. I then divide by 4. And so that gets me 2 because I have to get that square root isolated. Now, how do I undo square rooting something? Opposite of square root is square it. So I'm going to square both sides. So that gets me 2 squared is 4. 4 equals x plus 9. I then subtract 9, and I get -5. Now remember though, we can't just write the x-intercept like that. We have to write it as a coordinate point. You will lose credit if you only write x equals -5. You have to write it as a coordinate point. Let's talk about the y-intercept. So the y-intercept is where x is 0. So I plug in 0 for x. 0 plus 9 is 9. Well, square root of 9 is 3. 4 times 3 is 12. 12 minus 8 is 4. Okay? But remember, we can't write it like that. We have to write it as 0, 4. All right? So that's our x and y intercept. Now, we always want to check both solutions in the equation to make sure that none are extraneous. So if I plug -5 back in, I get -5 plus 9 is 4. Square root of 4 is 2. 2 times 4 is 8. 8 minus 8 is 0. So that works. And then if I plug 0 in for x, 0 plus 9 is 9. Square root of 9 is 3. 3 times 4 is 12. 12 minus 8 is 4. So they both work. Now, one little thing I want to point out. If you completely understand what we did right there for the x-intercept, that's the basic idea behind day 2. So if you're like, oh man, that was so easy and so crystal clear, you're going to do great on day 2. If not, we'll continue to, show you different examples. And so that way, by the end of day 2, everybody will be super awesome at solving for the x-intercept. All right, let's look at another example. Now, what do you notice that this example has that the other one did not? It's got a b-value. Our other example didn't have a b-value, but this one does. So we're going to have to talk about, is graphing it any different? Not really. Not really, okay? But remember, anytime you have a b, the first thing you need to do is you need to factor that b out, okay? You need to factor that b out, okay? Because that's where a lot of you guys got hurt on that 4143 quiz, is you forgot to factor the b. Got to factor that b, okay? Because you can't go, oh, my h value is -8, because it's not. You have to factor the b out. Super major important. So when I factor the b out, I get negative 2 times the square root of 2 times x plus 4 plus 10. So our a value is negative 2, our b value is positive 2, our h value is negative 4. Ooh, be careful, opposite day, so it's negative 4, and then my k value is 10. If I wanted to find the initial point, remember that's hk, so it's just negative 4, 10. Now, let's talk about graphing it. So we still start with our parent function table, guys. Nothing has really changed. But how am I going to go from old x's to new x's? Well, underneath the radical, it says I'm going to multiply by 2 and add 4. But remember, it's opposite day. So opposite of multiplying by 2 is divide by 2. Opposite of adding 4 is to subtract 4. So I'm going to divide by 2 and subtract 4. So 0 divided by 2 is 0, minus 4 is negative 4. 1 divided by 2 is 0.5, minus 4 is negative 3.5. 4 divided by 2 is 2, 2 minus 4 is negative 2. 9 divided by 2 is 4.5, minus 4, 0.5. 16 divided by 2 is 8. 8 minus 4 is 4. So that's how we go from old x's to new x's. To go from old y's to new y's, we're going to multiply by negative 2 and add 10. And so we get the following values. And then we simply graph the points, connect the dots, and there's your curve. Let's look at this example. It says, now try this equation by factoring the radicand. Guys, the radicand is a fancy name for, this is the stuff underneath the radical. Okay, so the radicand is the stuff underneath the radical. Okay, so this has got a b value of 4. So let's look. If I factor out that b value, that gives me y equals 3 times the square root of 4 times x minus 3 plus 2. Now, what do you notice about this b value in relationship to the square root? The b value in relationship to the square root. It's a perfect square. So I could take the square root of 4. Because remember, we have that rule regarding square roots that if we have the m times n, so if we have the square root of m times n, that's the same as the square root of m times the square root of n. So we can break up the product of those two and do the square root and then the product. So I can break that up into the square root of 4 times the square root of x minus 3. Okay, now in this case, 4 is a perfect square, so that's 2. And then 3 times 2 is 6. So by breaking up that product into the product of two square roots, that made us get rid of our b, and now it's easier to graph. And this will produce the same graph, maybe not the exact same coordinate points, because it'll be a little bit different, but this will produce the same overall graph as if we divided by 4 and then added 3. Now, keep in mind, we can only do this if the b value is a perfect square. If your b value is not a perfect square, you cannot do this. Okay, it won't work. You have to do where you divide by b and then whatever. Okay, now some people may ask, well, if I don't want to do this or I don't recognize this, can't I just divide by 4 and then add 3? Absolutely, there is nothing wrong with that. We're just showing you if your b is a perfect square, here's another way to tackle the graphing to make your life easier. So you can divide by 4 and add 3, or you can simplify it and then just add 3, and that'll change your y values as well. All right, so let's move on. All right, so here's what we want you to do. I know we really don't have table partners. I mean, I guess if you're in breakout rooms, that could be fun. But Anyway, so what we want you to do here is we want you in your groups to go through and complete the following tasks for this equation. Okay, so I want you to complete all 9 tasks for this equation. So I want you to hit pause, do all 9 things, and then hit play, and we'll talk about the answer. All right, this is what I got for the answers. Okay, last example. They want us to graph y is less than 2 times the square root of x minus 3 plus 5. Okay, so guess what? Just because it switched from an equation to an inequality, the steps for graphing are the same. It's just we then have to look at, are we going to use a dashed or solid curve, and are we going to shade above or below the square root function? So steps for graphing are the same. So I start with my parent function table, and then I say, okay, how do I go from old x's to new x's? I'm going to add 3. So 0 plus 3 is 3. 1 plus 3 is 4. 4 plus 3 is 7. 9 plus 3 is 12. 16 plus 3 is 19. Now, how am I going to go from old y's to new y's? Well, I'm going to multiply by 2 and then add 5. So I get these values. Now, chances are you going to be able to graph this point on the graph? No, don't change your scale. I want to see it on your table, but you may not be able to put it on your graph, okay? And that's okay. But I do want to see all 5 points in the table. So there's my 4 points. Obviously, again, I couldn't graph 1913. And now I have to look, well, it's strictly less than. It's not less than or equal to, it's strictly less than. So that means I'm going to use the dashed or dotted curve. So there's my curve. Now less than, that means I shade below. So I'm going to shade below this curve. But be careful. Notice that I did not shade beyond this initial point. I did not shade beyond that initial point, and you don't want to shade beyond that initial point, because if you shade beyond that initial point to the left, you're not going to get the right answer. You're going to get your graph counted wrong, because your graph does not start until the coordinate point 3, 5. So you cannot shade anything to the left of 3, because that would be incorrect. So this is how your graph looks. All right, and that is it for your very first lesson back from winter break. Your homework is worksheet 5A.1, and that is in the assignment with this video, and the answer key is provided. All right, so I hope everybody has a great day. Please remember to wash those hands. Please social distance, and please take care of yourself and make good, safe choices. And we will see you back for 5A.2.